so far I talked about the hardware, getting it set up, getting the program set up, getting the camera physically there. That's already done. The next section, before actually getting into the actual programming, is how vision works. And I think this is really cool. It's important to know how it works. If you know that, then you'll be able to implement the program so much better. Okay, so this section is all on theory of how you're supposed to, or how the camera works and how the system works. So when you go program, you'll have a much better idea and know what you're doing. So the first thing I wanted to go over is first you have our camera. And you've got an imager chip. So on this chip, just like a TV or a lot of the other, you have, and typically in our camera is 640 pixels by 480. So 640 by 480. I'm not going to do the whole thing. But you have these tiny little dots, which means you have 307,000 pixels. So the camera image has 307,000 little images, or not images, but little spots where you can take an image. Okay? And what it does is it stores that information as a voltage, but that voltage is equivalent to the grayscale. So black, if I'm on a black surface, I will have 0. So this would be all zeros. If I took a picture of a black piece of paper, this would be all zeros. Brightest being white. If I had a picture of a white piece of paper, it would store in each one of these pixels, so 307,000 times, it would store the value 255. Okay? So in the case of our domino, if our domino is here, it's pretty white, right? So in these pixels, it would have 240, 230, a high grayscale number. And then the area around the domino, right next to it, would be probably around 100 because it's brown. Everybody see that? So you've got, as it snaps a picture, 307,000 little grayscale values get input, depending on the shape and size and orientation and the values of whatever the picture you're taking. So again, my domino on this, if this area is my camera view, these will be high, and then right next to it will be lower values because it's brown. And what I'll probably do is paint this thing black so it's really clear on the contrast. Everybody see that okay? On it was on it. Okay with that? So you've got basically 307,000 little light meters. Taking a picture and storing the grayscale value. So in this case, this diagram shows 64 pixels, 8 by 8. And when the imager, the camera takes the picture, it has two different properties. This one is its location. Right, so this would be, this image would be 1, 1. This little dot here would be 1, 2, or 640, right? This dot here would be 480 and 1. This dot here would be 480, 640. And every one in between. And And not only does it have the location, it has the grayscale value. So if my domino's here, in location 240, 320, it would have 240 would be the grayscale value. So it has 307,000 values of this surface. So here, you can see it's the same property. Here it's white. All this is white, right? And then there's something in this image that it took that's a little bit darker. It has less grayscale value. So it's darker than, it's a dark object, or medium dark object. It also has another object over here. So that's how, through contrast, the camera sees an object. And contrast is so important in vision systems. So if I had a brown domino and put it on there, it wouldn't work very well. Or if my domino were on a white surface, it wouldn't work very well because the camera only sees grayscale values, so it looked just like its surrounding area. So in order for vision systems to work, you need contrast. You could, but it's still going to read, black on black is still the same value. So the cameras for these robots are only white. You can do color. That's what I'm saying. You can. So does everybody have a good idea when the camera now takes a picture of that domino and that, what it actually sees, what is fed back? So this would be domino, these values, and then outside of it would be, in this case, lighter. So that's inverted, really. That's how it can tell what the part is. So once it has that part in its memory, it's assigned a grayscale value. And then it looks for contrast. So it sees all these as 0, which would be what? What is 0 equal to? So it sees all this black, and then all of a sudden in these pixels it sees light, more light. And it recognizes the difference in contrast. And so now you know where these differences in contrast are, and it interpolates a line based on that, or a shape, or a part. So that whole pixel doesn't have to be just one color. So that individual pixel, you need two different colors. Which, this is an individual pixel. No, this is an individual pixel. Okay. So this one it read 0, the pixel next to it read 128, the pixel next to it read 255. So it went from black to white, but because
there's a little bit of shade there.
A little bit of shade or transition. So I just draw the line there. Okay. So that's how it gets the shape. So in this case, there's some black objects of this shape sitting there, and it took a picture of it, it translated those grayscale values, and looked for the transition. And this is where it saw the transition, so this is where it put the line in. So that's how it recognized the shape. So yeah, I found this part of the lecture pretty interesting because it's kind of magic how it does it, but it's really not magic. It's really simple. Then you got high-tech, 307,000 pixels all recording information. That's high-tech. But once you know that, Just looking for contrast, and that's important. Okay? Exactly right. There's a whole section on lighting. So before you actually run something, lighting has to be set up and done properly.
So this room would be okay.
It works. Obviously, it works. But you probably want better lighting if it's sort of production operation.
I can light on the camera itself.
Yep, and I'll show you that. So they explained it much better. So they find part edges when it scans the part, or takes the picture. Light to dark, dark to light transitions are noted, and then the pixels are linked together to form an edge. That's an important term, edge. And so that's how you get your part. You go from 0 to 128. It accepted it as a difference in contrast, right? That's called the threshold. Well, what is that threshold? The threshold is a user-defined setting. So you can make that threshold high or low depending on how much you want to read, how much contrast you have. So it's a setting. So you have, does everyone understand what threshold is? If you made your threshold very, very low, meaning I need 100 points or 200 points difference, it's going to be harder to find that line. If you made your threshold 5, right, just a difference of 5 in contrast, it's going to find a lot. So that makes a huge difference on the image, the same picture. You get 2 or 3 different results depending on the threshold when you set.
Does it have a default to it?
It does. It does.
So if the edge of the part is right here, but it's showing it right here.
Well, let's say you've got a bunch of pixels, and I'll make these a little bigger, but these are pixels, and you've got 0, 50, 128, 140, 255. Where are you going to draw that line? What contrast level? If your contrast level is 20, it's going to draw the line here. And here, and here. If your contrast level is 100, it's going to weight the line here, because that's where the difference of 100 is.
So basically I can control where it sees the edge.
That's right. So you look at your part, and what is the contrast of your part versus the background? Is it a huge contrast? Then you want to make that threshold a little bit higher.
Look at the brown on black.
Yeah, might have to make it a little lower, won't see it. It'll come up as not seeing anything. So the threshold is a very, very important number. So the threshold looks at the difference in contrast, and you set it at how much you want to allow it before it starts defining the edge. Another important concept is resolution. And resolution is the extent to which the machine can actually see the part or make distinctions. For instance, the more pixels in the camera's view, this would be the field of view, the area that the camera can take the picture. So both have the same field of view. The more pixels per part, the better the resolution. Because this has, basically, if there are, this is about 1/10 the size, say. So you've got 10 times the amount of pixels that you can use to define your part. Here you have fewer pixels that are able to define your part, making it much more difficult to find the contrast and find the line. So the resolution is very important. The better the resolution, the more likely you are to find the true edge of your part. Okay? So what that does is what makes that important is your field of view. Size of the picture you take. For instance, your camera's set up, and if your camera's really far away, and there's your field of view. If your camera's really close, you have a smaller field of view. So where your camera is located is very important. It determines your field of view. So you notice on this little example, the domino is really good size resolution. If the camera were further away, it'd be harder to see the domino, harder to find the line. Got better resolution. Any questions on resolution? You can see that they took a picture of this, and here's white, and then the actual part starts to get gray, and then it's really dark. So here's the contrast that it's seeing, and it's increasing contrast, right? Well, if you estimate a line with 4 pixels, here are just 2 pixels. So if you had only 4 pixels, the line would be estimated like that. Then the more pixels you had, so if you have 16 pixels, it sees the gray and contrast more clearly. With 64 pixels, it's a much sharper line. And then 256 pixels comes much closer. So that's important to see how it measures the contrast. If you have fewer pixels, it doesn't see the lines clearly because the contrast is not as obvious based on the number of pixels. More pixels, it can then have more opportunity to connect the lines in the right way. Okay? What's that?
The camera gets away from the robot itself.
And there's 2 ways around that. The easiest and simplest way is to mount the camera on the robot. Very, very common. And then otherwise you have to do programming around the camera. So you can see that lighting is very important because the shape of your part comes from the contrast. So how you light it will change the contrast of your part.
So the light should be far apart, and the light should be right above the part.
No. No. And I'll show you. So they've got bright field versus in dark field light. You know, light reflects the angle of incidence. Physics 2, is it? May or may not have had it. So depending on where your light source is, if your light source is over here, it's going to reflect out. So that's how your camera will pick it up. So you can see how, as your light comes in, it reflects out. So it's not, or I should say, this field is darker. And it's very dark here, and then as your light gets shown, you have light in this area. So you've got your bright area and your dark area. So depending on your field of view, how you're looking at it changes light versus dark. So that's if it's directly overhead. So depending on how you want your part, you can have your light over here. And this is a rough surface. So your light is going to bounce off this rough surface. So you can see how your light comes in and bounces. And here, the same part bounces differently, but on this part, if your light is underneath, right? So directly underneath will show this part very well, right? But won't show contrast to these parts. Everybody see that with the domino? Get your light underneath. You see the edge of the domino, but it is very difficult to see the holes in the domino. Here, a side light. That's how the light shines and reflects a couple bumps. Here, directly overhead. That's one for that. So it depends on where your light is as to what it will show. It's good information. Successful vision applications about creating optimal contrast between the feature, right, the part you're interested in, and the background. So in our case, this doesn't really help much, but we're interested also in the inside. So contrast is achieved by, you really have to know more than just the shape, but the surface texture, the color, translucency, will all affect how your lighting is.
So we can put like a flat piece of paper.
That would help out tremendously. This is a nice little matrix of lighting solution versus lighting problems. If your shape has notches, stampings, things like that, or your surface texture, polished metal, or sandpaper, your color, so there's your variety of color, or your translucency, they give you probably the best type of lighting to choose. That's a neat little matrix. And you have a lot of different choices. You can use backlighting, directional lighting, depending on the angle you want.
So directional lighting. Backlighting.
Much like in your robot presentation, right, depending on where the light was, gave a different image of the robot behind the curtain. This is kind of a neat section. It kind of gives you an idea of how lighting really affects the part. This is like a ring lighting. So the X surface and radius section, because of this type choice of lighting, it shows that very well. So they changed the lighting. Now you can see these clip edges pretty well. And then a dome light, instead of the ring lighting, gives you a third view. How do you look at it? So it depends on what you want to pick up. If you wanted to see this edge really well, you'd use the ring lighting. If you wanted to see this, you would use that first lighting. This dome lighting gives you a good outline of the part. So it depends on what you want to look at. Depends on what you want to inspect for. If you did backlighting, see one black blob, it picks up the outside of the part really well. So just with lighting changes, it gives you a completely different image. So depending on what you want to do with the part. If you want to inspect it for length, if you want to pick it up by a clip, if you want to use that etch surface for some reason, or read that etch surface, the lighting you use will make a huge difference.